In this demonstration, we're going to be showing the neutralization of milk of magnesia, which is magnesium hydroxide, with hydrochloric acid. Because this reaction generates a lot of heat, I'm going to add some ice to my beaker. And for this reaction, I'm going to be adding the milk of magnesia, which is about 1/3 of the dose that would normally be used for neutralizing stomach acid. So I'm going to go ahead and add this in. Magnesium hydroxide happens to be a slightly soluble substance. So some of the magnesium hydroxide is going to dissolve in the cold water, and it's going to make a basic solution. So we're going to be able to measure the pH with our pH meter in the background. So we're going to go ahead and start our pH meter. And we're seeing right now that our pH is in that basic range. It's up around 9.8. And as more of this magnesium hydroxide continues to dissolve, we're going to see this pH continue to increase. What I would like to do now so that we can see different ranges of the pH, I'm going to add a universal indicator in addition to the pH meter. This is kind of nice because you're going to see a lot of different color changes. So in basic solution, this universal indicator kind of has this nice pretty bluish color associated with it. So what we're going to do now is we're going to try and neutralize this solution by adding some 6 molar hydrochloric acid, same acid that's in our stomachs. So let me go ahead and add some of this, and let's see what changes we see with our pH meter as well as our color changes. As you can see, our solution just turned red, which is more indicative of an acidic solution, but there's plenty of magnesium hydroxide still in there, and you're seeing that we're going through the color changes as our pH is continuing to rise back up above 7, and eventually it's going to be back in that basic range, and it should reach its way back up to the pH of 9 to 10 that it was initially before I added the hydrochloric acid. So I'm going to let this pH continue to rise because remember, magnesium hydroxide is a slightly soluble substance, so we're constantly releasing hydroxide ions into solution. Now that the pH is getting back up around 9 or so, I would like to actually show the color changes again. This can be done several times. So let me add some more 6 molar hydrochloric acid and see if I can neutralize some of those hydroxide ions that are in solution. So I'm going to add some more 6 molar HCl. Once again, we see that pH range significantly drop, and we're seeing the color changes as we're going through all the different pH ranges again. And this process can continue as long as there's still some magnesium hydroxide in that solution. Eventually I'll add enough hydrochloric acid that I'll neutralize all of the magnesium hydroxide and the process would remain red. But right now we haven't got close to that. I can continue adding hydrochloric acid to this mixture, and we'll see this exact same process. I'm going to add a little bit more HCl. This time I'm going to add it a few drops at a time. As you can see, we're having quite a few different color changes occurring with just a few drops of this. Once again, this is the same stomach acid, HCl, that the magnesium hydroxide is designed to neutralize. And eventually, if I add enough HCl, I can get this to turn red and stay red. But at this point, we probably still are going to have some magnesium hydroxide that hasn't dissolved in solution. More than likely, it's going to turn back to the darker color, as you can see in front of you. So what you guys are able to see here is a nice acid-base neutralization reaction. We're able to see the pH changes right here on our screen with the graph. Nice little demonstration to depict not only acid-base indicators, but the idea of neutralization with a commercial product.